Hi there. In this video, we're going to take a look at how to take our analyzed data and form a conclusion that's not only correct, but it's also very clearly backed up by the data we just did. This is one of the big errors I see when I'm looking at IAs, is that people spend all this time on experiments and gather all the data, and then the conclusion just never talks about the data. So if you can see on the screen here, I have I've went ahead and moved from Excel into Word, and we're typing out our analysis and conclusion section. So in the analysis section, I always like starting with the raw data. Notice how I've numbered every single table. That's if I want to talk about that table later in the paper, I can just refer to the number. I don't have to describe what table I'm using. In this case, I made two separate tables of raw data, one of them for series and one of them for parallel. Remember, raw data is exactly what you get from the experiment. It's nothing you've done any math on. It's just pure numbers from the experiment. Now, after the raw data, I put the process data. Of course, process means you do math on it. And before the process data, I'm going to describe a little bit of what I'm doing. I'm not necessarily talking about why, but I'm just going to explain what's going on, what equations were done. Remember, I can't see what you've done in Excel. I need to read about what you did. So you certainly need to explain what equations you use and give some examples. I can see here I gave an example set from my data. So below I have, I include some raw data, the voltage, number of resistors. Now I've put the current in amps. I've gotten rid of the milliamps because that is a number I did math on. And I put the resistance. Of course, that's what I calculated also. I've also got the chart. I made it as, you notice the axes titles here with units, total resistance in ohms, number of resistors. And you can see the title is, again, numbered. This is chart number 1, so I can refer to it later, and you see I will. In this case, it was a linear fit. I included the equation there, and this looks quite nice. Now, below that, I put the stuff for parallel, and I just basically said I did the same as above, but I indicated that I did raise the number to the -1 power. We'll see, we'll talk about why I did that later. But again, you can see my process data. Again, this is table 4 if I need to refer to it later. Now below that, I put chart 2. This chart I included because I thought it was important. I'm not going to necessarily refer to this a huge bit. I could, but I included it. But I also included chart 3. This is really the important one, and it's total resistance versus the inverse of the number of resistors. Now notice one thing I did here. In Excel, you can't do superscripts. It just won't let you. In Word, you can. When I pasted this from Excel, I had that caret there. It looks a little messy. I went ahead and cleaned it up. You'll notice I did that down here as well. It just looks a little nicer. Notice also I have no units for number of resistors. Number doesn't have a unit. It's just a number. So this is my analysis section. Analysis is where you take the numbers and you tweak them. A lot of this is done in Excel and just copied over. You never want to submit an Excel document and a Word document. Go ahead and put it all together and make it look nice. I go below here to conclusion. Now the conclusion is one of the tougher parts for students because they're good at drawing a conclusion, but they don't describe why they get that conclusion. A lot of time I see things like, as you can see from my data. Stay away from that phrase because I, as the reader, am not supposed to see anything. You are supposed to explain things for me. That's the point of a lab report, to show that you understand what's going on. So if you'll notice what I did here, and I have uploaded this to ManageBack, so you can take a look and see how it works. But if you see here, I'm explaining, I'm showing the equation, I'm talking about what I did, I'm talking about how I simplified this equation to this equation, I'm defining some of these terms, and then I'm laying out the fact that if the equation we know, if this equation is true, then I would expect the graph to be linear, pass through the origin, and then I say, as you can see in chart 1, notice I don't have to describe which of my 3 graphs to look at. I just say chart 1. I say this happens. You can see that it happens and indicates that the equation is correct. Did the same thing for parallel. Just had to add that little bit about raising to a negative power. And again, as you see in chart 3, this equation is correct. Now, in talking about the individual resistance, I wanted to talk about how I find the resistance from the graphs. I showed the equation. I explained that the R value is the slope of the graphs, chart 1, chart 3. I gave both values that I found, and I indicated that they were very close together, found percent difference. I also said they're within the actual value. 150 was the actual value of the resistors. Now, one thing I left out here that I probably would add in a later paper, we haven't really talked about this yet, is some talk about uncertainties. One of the things you do need to pay attention to is the uncertainty. How sure are you of that voltage? And when in your conclusion, you want to talk about whether these values would match the known value within the uncertainty. And in this case, they certainly would. We're going to talk more about uncertainties later. Right now, I want to focus on making sure you understand how to do a lab report. But this conclusion, I feel, is pretty valid. If you look at the examples of what IB says, they say conclusion is described and justified. It is relevant to the research question. In this case, we had 2 questions, but whatever. And it is supported by data. And I feel that this conclusion did both of those things very well. I also see the conclusion is correctly described and justified. Relevant comparison to accepted scientific context. I certainly did that when I talked about the scientific equations we already had, and I compared my answer to what I knew the value actually was. So I think I would meet that standard as well. Hopefully this helps you set up your conclusion and your data section. As you can see, this is 5 pages. That's a lot of text, but a lot of it is just copying from Excel, and you see these graphs are really 1 page to themselves. So don't worry about using too many pages. You want to make sure you lay it out there for you and include all the data.